Hello students, next question. We are solving previous year question. A pond appears to be at 2.7 meter deep. If the refractive index is given 4 by 3, find the actual depth of the pond. See, when any, this is a pond, okay, when you see any pond, it appears to serve a certain height due to refraction of light. Okay, A mu G is equal to A mu W. Okay, absolute refractive index is we can say uh, real depth upon apparent depth. Okay, so what is the refractive index given 4 by 3 and apparent depth 2.7. This is, I will solve 4 by 3. Okay, so this is given 4 by 3 is equal to real upon apparent. So apparent depth is 2.7. So you can multiply 2.7 into 4 upon 3. So this is the 10. You can do 9 3 are 27. Okay, so you will get 9 4 is 36, 3.6 something. So this is the answer. The real depth is 3.6. Okay, so real depth upon apparent depth, this is the question. 2.7 is the apparent depth. So you can use this formula. You can solve in this way. Now next question. Complete the path of monochromatic light AB incident on the surface PQ. Equilateral glass slab. Okay, this is the equilateral triangle. It is 60 degree. It comes like this, and this is the path A and B. This is the normal. Okay, so this is the question. This is the question. They have not mentioned 60 degree. Complete the path of monochromatic light ray AB on the surface PQ. PQ, R is the surface, R is the right angle triangle, not right angle, equilateral triangle. So this is equilateral triangle and emerges out of the prism due to the refraction. You need to draw a complete diagram. So make a parallel line. This is the parallel line. This is the refracted ray. This is the incident ray, and draw normal. Oh no, sorry, man. Draw normal. Okay. This is the normal, and the emergent ray goes like this. This is the emergent ray. If this is a 60, it will be 120. Okay, and this will be 30, and this will be 30 because sum of the three angles of triangle is 180 degree. So this is the path ray when you put any plane mirror over here. Okay, if you put any, I am explaining little ahead. So put any plane mirror, this ray will reflect it back to the same path. This is called principle of reversibility. Okay, when the light travels through this path, this will come to the same path, back to the same path. This is a principle of reversibility. So when light travels this way, this way, this way, This is the emergent angle, this is the refracted angle, and this is the incident ray, and this is the incident angle. Okay. So this is the question. Complete the path of monochromatic light. Monochromatic light means the light having single color. Okay. Chroma means color, single wavelength. What is the relation between refractive index of light with respect to air and water? A mu g and g mu a. If the refractive index of water given, this is the question in 2019. 2019 this question they have asked. So I am going to solve this question. See this question. See, a relation between refractive index A mu W. This is water. Okay. Relation between A mu W. This is normal. This is incident ray. This is angle of incidence. This is angle of refraction. And this is angle of emergence. Okay. So when you go like this, these two rays are parallel, and this distance is lateral displacement, perpendicular distance between these two. Now they have asked you what is the relation between A mu W. When light travels from air to water, the refractive index is A mu W. This is called absolute refractive index. Okay. This is sine I upon sine R. But this angle is R1 and this angle is R2. Okay. So sine R1 is first angle. So this is the incident refracted angle. This is the incident angle. When light comes, it bends towards the normal. Now light coming from water to air. This is the water to air. Refractive index of air with respect to water. Means whatever the light travels from water to air, air to water. Okay. This would be sine of angle R2 upon sine of angle E. Okay. This will be angle E. Now here light travels from air to water, okay. So this will be refracted angle, this is the incident angle, this is the emergent angle and this is the refracted angle. But for this it is an incident angle. So product them A mu W into W mu A is equal to sine of angle I upon sine of angle R1 into sine of angle R2 upon sine of angle E. E is the emergent angle. Here, this is the velocity of light in air, this is the velocity of light in air. So, both have same angle, means I is equal to E, and these are the alternate opposite angle. This is the R1 and this is the R2 Z. This is the alternate opposite angle. R1 is equal to R2, means both are same. So R1 is equal to R2 will be cancelled out and I is equal to E. This is cancelled out. You will get answer 1. A mu W into W mu A is equal to 1. Or you can say W mu A is equal to 1 upon A mu W. This is the relation you can say. Now the question they have asked, refractive index of water with respect to air. Refractive index of water with respect to air means light is the refractive index of water with respect to air, means light travels from air to water. is given 5 by 3. Is given 5 by 3. Calculate the refractive index of air with respect to water. Calculate refractive index of air with respect to water. Now the light travels from water to air. This is you have to find out. When you see, when you are seeing water directly, means swimming pool. This is the refractive index of water with respect to air. When you jump into the swimming pool and sit at the bottom and you see the person outside the swimming pool, this is the refractive index of air with respect to water. So you have to find out W mu A. Now they have given, this is given. So A mu W into W mu A is equal to 1. Now you have to find out this. So W mu A is equal to 1 upon 5 by 3 means 3 by 5. This would be the right answer. So 3 by 5 is the answer of this question. Now they have asked question why the ratio of velocity of light 4,000 angstrom and 8,000 angstrom in air is 1:1. This is question they have asked. Now we will solve this question. Means if the light is in air, the velocity is same. Okay. When it enter in the medium, its velocity changes and the wavelength changes. So they have asked question why the ratio of velocity of light of wavelength 4,000 8,000 Armstrong in air is 1. Wavelength is 4,000 angstrom and wavelength is 8,000 angstrom. The ratio is lambda 1 upon lambda 2 is equal to 1 because in air or vacuum the velocity is same. V1 is equal to V2. So velocity change means lambda 1 mu is equal to lambda 2 mu. V is equal to n lambda. N is the frequency. Frequency is same. Frequency will be cancelled out. You will get lambda 2 1 is equal to lambda 2. If lambda 1 and lambda 2 are same, means the velocity in wavelength is same is case of air. So velocity in air is same, in velocity air is same. So both wavelength velocity of both wavelength is same. So velocity of lambda 1 upon velocity of lambda 2 is equal to same. So that is called 1:1. So when light travels in air, the velocity is same, so wavelength is same. So when we go for the ratio, we get the answer 1:1. Next question. Next question. If the above wavelength is higher, which of the above wavelength has higher frequency? Now we know that in air, we are talking about air or vacuum. So, okay, air or vacuum, velocity is equal to frequency, we can say frequency and lambda. And frequency is inversely proportional to lambda because velocity is constant. Velocity is same in air. So frequency is inversely proportional to wavelength. So wavelength is 4,000 Armstrong and wavelength is 8,000 angstrom. So here lambda 2 is greater than lambda 1. If lambda 2 is greater means frequency of first is greater than frequency of second. Means frequency of 4,000 angstrom is higher than frequency of 8,000 angstrom because frequency inversely proportional to wavelength. So we discussed question up to 16. Now 17th question, how is the refractive index of material related to the real depth and apparent depth and the velocity of light in vacuum and velocity of light in medium? They have asked this question, so I will explain without writing on the board. So they have asked question what why the refractive index of medium is related with real depth and apparent depth. Refractive index is the ratio of real depth upon apparent depth. Okay, mu is equal to real depth upon apparent depth is the first answer. And next, velocity of light in vacuum or air and the velocity of light in medium. Velocity of light in air vacuum is always greater than velocity of light in medium because the medium has high density, optical density. Due to this reason, the velocity decreases. So, velocity of light decreases in the medium. So, we discussed 17 question total. So, 17 question asked in 2017 and this question we discussed 2018 and previous question 2019. Draw the ray diagram of the reflection of monochromatic light or the presence of a minimum deviation. So this question I am going to draw on the board. Already I discussed this question, but I will explain again. So when minimum deviation, when there is a minimum deviation means when light comes like this, it is a normal. Okay, oh, sorry man. This is the normal, this is the normal, and this is the incident ray, and this goes parallel, and this goes emergent ray. And now draw. This is the angle of emergent. This is the angle of R1, R2, and these are same. R1 is equal to R2 and I is equal to E because at the condition of minimum deviation, this ray goes parallel to the base. So this angle is equal to this angle and this angle is equal to this angle, and though both rays are parallel, this is the condition of angle of minimum deviation. So we discussed the near about 18 question we discussed, and calculate the refractive index of the liquid with respect to air. Angle is given. So this question we are going to solve. Last question we are going to take. Next lecture I will discuss other questions. Now question is 45 degree and this is the incident ray, this is the refracted ray, this is the angle of 45 degree, this is the angle of 30 degree. I made wrong, it will be 45 degree. So if this angle is small and this is angle big means this is a denser medium, this is the rare medium, means this is a oh, this is a 30 degree and this is a 45 degree. Now if this is a 30 degree means 90 minus 30 is 60 degree. This is the angle of incidence. Okay, the question is very tricky. So you need to understand this is the rare medium and this is the rare medium, denser medium. This is the liquid. This is the liquid. Calculate the refractive index of a liquid with respect to air. Snell's law. Okay. So if this angle is 45 degree, this angle is 60 degree, mu is equal to sine I upon sine r. What is sine I? Sine I is a sine 60 and sine r is a 45. Sine 45. Now, what is the value for sine 60? That is a root 3 by 2. Okay, root 3 by 2 and sine 45. Sine 45 is 1 by root 2. Solve this, you will get root 3 into root 2 upon 2 into 1. So, you will get the 2 value is root 2 into root 2 you can write. Okay. So, this root 2 will be cancelled out. You will get root 3 by 2 is the right answer. In this way, you can solve this question. So, this was a very easy question. You can solve. But trick is that here the angle is 30 degree given. You have to find out the angle of incidence 60 degree. Sin I upon sin R you put, you will get the refractive index of a medium. So, bye bye students. Have a nice time. God bless you all.